right. Hello, everyone, and welcome to another episode of Containers from the Couch. Today, we've got an exciting episode talking about the recently made general availability of EKS Anywhere on Snow. Today, I've got experts from AWS ready to talk about what this release means for our customers, for our users out there. So let's quickly go around the circle here. Tell us a little bit about yourself. We'll start with you, Edric.
Yeah, hi everyone. I'm really excited to be here today. I'm Edric. I'm a senior TPM on the AWS Snow team, and we've been working with a whole bunch of teams to bring all these different products together into an offering that we definitely want to talk and showcase today.
Awesome. Thanks, Edric. All right, next, Yishin.
Hi, this is Xin. I'm a software engineer on the AWS Snow team. I have been working on this EKS Anywhere on Snow project for about 1.5 years. Super excited to be here. Thank you.
Awesome. Last but not least, Ila.
Thank you, Sai. Hey, everyone. My name is Ilamaran. I go by Ila. I'm a senior container specialist solutions architect with AWS. I focus specifically for the partner org, and the reason why I'm in this call is to talk about the partner angle of the Snow launch. Looking forward for this conversation. Thank you.
Awesome. And Ila, we have you on the show. We've had you on the show before, not just to talk about that, but to get your insights here. And Ila's got a lot of great experience with working directly with customers in the EKS solution. So glad to have you all on today. It's always an exciting episode when we can get some technical folks on. We've got engineering, we've got TPM, we've got solutions architecture. So this is going to be a fun one. We've got demos lined up for you today. But before we get into it, I've got an awesome video from a coworker of mine. You may have heard of him, Justin Garrison. He makes a lot of great content on Containers from the Couch and his personal channels, but he's got this awesome short that he just made, published on Containers from the Couch, that introduces EKS Anywhere on Snow. Let's kick that off.
EKS Anywhere is the on-prem Kubernetes management platform from Amazon. It's open source and runs on multiple different platforms, and recently just shipped support for snowballs. So now you can take EKS Anywhere clusters anywhere.
Want a white noise machine with 512 gigs of RAM? That's the sound of over 100,000 pull requests.
Speaking of PRs, power yours with one of the largest open source projects and 42 terabytes of storage. Pro tip, you get more of a burn if you fill up the hard drives first. And with 104 vCPUs, you can run Kubernetes in Snow, on Snow, and not worry about getting cold. So if you're on edge about Kubernetes at the edge, bring EKS along for the ride.
Honestly, I love those shorts because I feel like it's such an easy way to understand something very quickly. But we've got a different format here today. We're going to take that and we're going to spend maybe the next 40 or 50 minutes or so diving in a little bit deeper for exactly what it means for our customers and users. Now, first, Edric, I want to start with you here. Tell us a little bit about this recent release for EKS Anywhere on Snow, and what exactly we announced.
Yeah, absolutely. We actually announced this on Valentine's Day, so pretty recently. And what we announced was EKS Anywhere on Snow, which is a new deployment option for EKS Anywhere, where we bring EKS Anywhere onto the Snowball Edge Compute optimized devices. So it's sort of a natural progression and a collaboration in sorts. And what this means for the customers is that they get the simplicity of ordering Snowball Edge devices directly from AWS through the AWS Snow console, but they can roll in their Kubernetes workloads directly at ordering time. So when they receive the devices, it's all up there, it's all ready to go, and they can kind of get on with what they need to do straight out of the box.
Absolutely. So, there's a lot of different ways we enable our customers to be able to run Amazon EKS. Of course, our in region, in cloud, we have Amazon EKS being our managed Kubernetes service, but we also provide distributions to enable you to run Kubernetes at the edge in hybrid environments. And so notably, there's a few different ways we enable customers to do this. Of course, Amazon EKS referring to the managed service, but we have different options for running it on hybrid and edge as well. Notably, Amazon EKS on Outposts and Amazon EKS Amazon EKS Anywhere. Now, Ela, I want to give this to you. Tell us a little bit about what's the difference between Outpost versus EKS Anywhere when we're considering wanting to run Kubernetes.
Yeah, absolutely. That's a great question. So talking about EKS Outpost, so the idea is that you build local clusters with the Outpost machine on your data center. So which means that you're going to buy the Outpost machines to your data center, and you're going to build local clusters with EKS. So that's pretty much with respect to Outpost. But when you talk about EKS Anywhere, the idea is that you can take an EKS Anywhere distribution from AWS, and you can deploy that into a vSphere environment, a virtual environment, or you can deploy that in bare metal, which is basically non-virtualized environment. And then you can also deploy into Nutanix. We do support Nutanix today. That's another hyper-converged environment where you can deploy EKS Anywhere. And apart from that, with the Valentine's Day release of On the Snow, so which means that you can also deploy on the edge using EKS Anywhere. So that's the fundamental difference, right? You're going to take a distribution and deploy that into your hybrid and edge environment versus you use the AWS hardware, basically the Outpost, and you're going to deploy EKS there. So that's the fundamental difference between these two distributions.
Yeah, I love that we released this on Valentine's Day, because I feel like we talk a lot about how EKS and Snow have for a while been kind of these separate entities, and it's almost like this love story of coming together, supporting EKS Anywhere on Snow devices. That's awesome. Now, one of the things that I think I made a video a while back comparing EKS on Outpost and EKS Anywhere. In that video, I talk about how Outpost, you're getting hardware from AWS, and with EKS Anywhere, you can run it on your own hardware. But with this particular way of working with EKS Anywhere on Snow, you're getting Snow hardware from AWS as well, right?
That is correct. Yeah, we are going to get the hardware from AWS shipped to you, and then you're going to use that to deploy EKS Anywhere, which means that it's basically an edge computing enablement that you're getting with this particular launch of Snow.
Okay. So, but if I wanted to lay it out differently, so fine, you can get hardware from AWS, whether you're running EKS Anywhere or whether you're running EKS on Outpost. But specifically, I think EKS Anywhere, what I saw on the blog, is an acronym called DDIL environments, rugged edge and DDIL environments. Edric, do you want to talk a little bit about that? What makes EKS Anywhere more geared for these types of environments?
Yeah, definitely. And I think DDIL, in the Amazon way, we always want to define what our acronyms is. Hopefully I'm getting this right, because we use the acronym so often, sometimes I forget. But
I'm fact checking you, by the way. I've got it in front of me.
Yeah, so I think it's normally, let's see, the two Ds always trip me up, but it's disrupted, disconnected, intermittent, or limited connectivity environments, or we can kind of wrap it all up and call them unconditioned environments. So these are places that are a little bit untraditional to normal compute, because you would normally imagine, like, especially when you're doing things in the cloud, it's generally like an ephemeral cluster that's running in a data somewhere. From a customer standpoint, you don't really know where it's running. But for DDIL environments, we're talking about on the field, right? You can imagine running a local cluster on a cruise ship, out in the field, doing research on a mining rig. These are at location, on-premise environments where you might not have a controlled environment, right? Like you want to be running out on the field. So Snow devices are designed to run in these environments. Not only do they have a lot of compute on them, a lot of storage on them, but they're also ruggedized. So if I think Ishan there right out of the corner is peeking out there a little bit, is an actual it's our device. It's one of the Snowball Edge devices. You can see it's a fully ruggedized case. We've done a lot of extreme testing on it. And you can basically just throw this out in the field and have a Kubernetes cluster up and running wherever you want it.
Yeah, as long as you have power, right? So I think that's what
as long as you have power. And we've seen people power these a whole different ways, like, standard out of the wall outlet, but we have other teams that have plugged this straight into like the back of a Jeep, plug them into like mobile power stations. Definitely very flexible there.
Yeah. Hey, by the way, the DDIL, you almost got it. It's denied, disrupted, and then interrupted and limited. So 3 out of 4. I'll give you a 75 on that, Edric.
I think that's a pass.
But hey, you pointed out you've got the snowball device right there. Yushin's in the office today. Can we take a look? Like, what does this thing look like?
Yeah, so I have two types of snow device here. The big one is the snowball. It's in the size of a check-in luggage. It's weight about 70 pounds. Oh, super heavy here. It has a
workout.
Yeah, front screen showing the device information, including the IP address, the storage, and memory and CPU address. And it also has a screen at the top. Let me show here. So here we display the shipping labels. With that, we don't need to like stick the shipping labels on the device. That makes the device more clear. And we also have a small version of the small device. It's called Snow Cone. It has less compute and storage power, but it's a very small and lightweight. Easy to carry.
So today, just to be clear, we're talking about the availability of snow on the snow device, not the snow cone, right?
Yeah.
Yeah, that would be pretty cool if we could get Kubernetes running on that little thing. But okay, today for now, it's that big snow device. How much does that weigh, by the way?
The bigger one is
the big one, yeah.
It's a check-in baggage weight.
Okay, so you can check it. Okay, so it's like what, like 50, 60 pounds? I'm guessing around there.
Yeah, 50 pounds. It's designed for the check-in.
Wow. Okay. Wow,
we definitely have people in our team when traveling for conventions. It's such a funny experience because they'll bring this to like a check-in counter, and then they always get weird looks. But it is conformant. It is at that weight limit, so they can actually check it in, and you don't even need to put the case around it. It gets just checked in as is, and you always get kind of funny looks like lugging this around airports. And
you probably don't want TSA to open that thing up, huh? But that's cool. That's cool. Okay, so we've talked about the release. We've talked about the Snow device, and the fact that we now support EKS Anywhere. But for our folks that are watching, why exactly would you want to run EKS Anywhere on Snow? What type of use cases do we have in mind?
Yeah, so definitely kind of, as we mentioned, DDIL, it's definitely targeted. It's bringing the value proposition of Snow and sort of what our Snow customers know and love, and extending that further and letting them run containerized application. Because I think prior to this, a lot of the customers have been running their workloads in these unconditioned environments as AMIs. And as they're modernizing and as they're coming up with new applications, they really want a platform that can run containers. That out of the box, they basically want a solution where they can bring a cluster wherever they need it and have it up and running. So we're kind of looking at different use cases such as cruise lines. We're looking at like mining operations. We're looking at a lot of defense customers are very interested in this, and we're also looking into other industries that might not be super obvious that they might be interested in this. But two big ones are healthcare and also disaster recovery. So we've done a lot of work with our disaster recovery team where they have to set up a mobile compute station somewhere in the field, and they might not know where that is until the day of. And these are the types of scenarios that we're targeting. A lot of our customers are asking for.
That's really interesting. One that seemed to come to mind that maybe you didn't touch on was telco. Are we seeing this have a big presence in telco?
Yes, absolutely. Can't believe I forgot that one. Especially from our telcos customers, like Snow is such an important platform for them because it's the marrying the two needs. The first is that they want to modernize, they want to be able to develop quickly, and as 5G workloads and their platform evolves, they want to be able to quickly test and develop, and they really want to close in on that cycle. But on the other hand, there's sort of like the infrastructure needs and the infrastructure asks, which are sometimes they are deploying these locations, the remote locations that don't have internet access, that don't have a backhaul link. So it needs to be able to operate fully disconnected, kind of on its own. And another thing to think about is also there's a lot of national sovereignty laws and privacy directions and trends that we're going into. And a lot of our telcos they want to design from a disconnected first scenario where most of the time the cluster will be connected back to a region. But if they ever have to disconnect it, they want to have the peace of mind that it will just continue to operate and their customers aren't affected by what sort of happens in the back end. Because at the end of the day, they want to provide their customers the best experience, the most uptime. So for us, like telco is actually a large user and vertical that we're looking into.
Thanks, Edric. So we have a question in the chat here. What's the difference between EKS Anywhere and Rancher RKE? And so I think Mikhail has already answered the question in chat. For one, these two aren't exactly comparing apples to apples. They're when we look at EKS Anywhere, really the distribution underneath the cover is going to be EKS distro. That's kind of more comparable to RKE. And so RKE is Rancher specific distribution. So you have a follow-up here. So you're aware it's a distribution, but what's the value of using an AWS provided distro? I'll take a crack at this first, and then maybe you guys keep me honest here. Realistically, the idea here is that we're enabling support for Kubernetes, and it's an AWS provided distribution. There are certain capabilities here that same distribution of Kubernetes being used on Amazon EKS in region and cloud, as well as in your on-premises and edge distributions, kind of gives you that single layer that you can kind of have consistent. In addition, we also work with vendors and partners to support their add-ons and their solutions through our curated packages framework as well. There's probably a couple other value adds I'm missing there. Anything else you folks want to add?
Yeah, I can add maybe. So basically, when you talk about this EKS-A distribution from AWS, it's also going to have the security patches and frequent updates from AWS. And that's a huge advantage in using a distribution. And basically, you're taking the complete distribution and deploying it into your hardware. So that's the fundamental difference and the advantage you're going to get by using this distribution.
Excellent. Okay, folks, I think we're all ready and eager to jump into a demo. I want to see how this stuff works. Yishin, you're our resident SME today. Are you ready to get started?
Yeah, I can start.
Let's do it. I'll bring it up now.
That's good. So
first off, Yishin, sorry to interrupt you. I want to just very quickly high level start with what do you plan on showing us today, and what are we looking at? Right, let's get that out of the way.
Yeah, I'm going to talk about that. So, for today's demonstration, I will going to demonstrate the cluster creation, and then I will show how to deploy a service on an existing cluster. And last, if we still have time, I will show how to do a simple upgrade. This includes the scaling up, and then at last, leave the cluster.
Excellent.
Okay. Yeah, then let's start the demo.
So Yishin, sorry, I'm going to interrupt you a lot. This is so you showed us the two EKS, the Snow devices next to you. Are these going to be running on those Snow devices today?
Yes, all the demo are running on 3 real Snow devices.
Got it.
But not this one.
Now that one, that's just for show. Okay, got it.
Yeah. Okay, let me start. So in order to create a EKS-A Anywhere cluster on Snow devices, we need to do some configuration before the real cluster creation. And we have an open source tool to help with that process. I already downloaded this open source tool on my client machine. So be able to use it, we need to first give some values to that tool. That's recorded in a file called config.vision. Let me open that file and talk about that. So in this file, I need to provide the device information. This includes the device IP, device manifest, and allow code. The manifest and allow code is used for access device. And we have 3 devices here. I will use these 3 devices to create a cluster. So to use multiple devices is to enable the high availability.
Okay, so we want to make sure we're using multiple devices to deploy our cluster. So realistically, we want to spread out our management, our master nodes, and our worker nodes here. The actual IP addresses, the manifest path, the unlock code, So I know there's like a screen in front of every Snowball device. Is that where you're getting this information from?
Yeah, so the IP address is getting from the front screen of the device, but the manifest and allow code we need to get it using the AWS Snowball CLI from AWS console.
Got it.
That's the device-specific credentials. Okay, then I can continue. So after we have the 3 devices ready, I also need to input some other parameters, including this Snowball Edge client path. This is the client we use to communicate with the device. And the EKS admin image ID. This is a pre-built-in AMI on the device. It has all the EKS-A artifacts built in. Yeah, we can specify an AMI ID here. We also can leave it as empty. If it's empty, the tool will try to find the latest version of the EKS-A AMI. And then we also need to provide the cluster name here. I call it demo, and the control plane endpoint. That's the load balancer IP for all the control plane nodes, a single access point for the cluster. And then we need to input the pod slider IP here. That's used for the pod network. And at last, the Kubernetes version. For now, we support 1.21 to 1.24. I'm creating a cluster with 1.23 to enable the version upgrade later.
Okay. Intentionally deploying an older version so we can show you how to upgrade it later. I like it.
Yes. So that's the configurations we need to input for the tool. And with all this setup, I can simply run the setup tool to let the tool run the configuration automatically. So that's the that's a script called setup.
So what exactly? Maybe you can show it after, but what's in that setup script? Is that just something the user has to configure, or is that just a standard setup script no matter where you're deploying?
Yeah, that's the standard setup script. User just needs to input the configurations in the config.json file.
Is there any other magic happening behind the scenes, or is this really it? You've SSH'd into one of the devices, you've provided it the config, and then you're running the setup script?
This client machine which has access to all the devices. We just have a machine that has access to the subnet of the devices, and then download this setup to change the configuration files, and then just run this script.
Okay. All right. I'll take your word for it.
Yeah, a straightforward script. So within this script, we will first unlock the device. You can see here the device already unlocked it. And then we will set up the credentials on its device. This credentials is for EKS Anywhere to access the on-device resource, including the IAM and EC2. Yeah, so you can see here we set up the credentials on each of the devices.
Wow. So it's doing basically everything I need to get a running EKS Anywhere cluster. I'm not gonna lie, this is pretty slick. This almost looks as easy as creating an EKS cluster with EKS Cuddle. It's managing the policy creation and all of that. I like that. That's very cool.
Yeah.
So under the hood, that is what it is doing basically, right? So it's using the EKS Cuddle, right, extension to create the cluster, right?
It's not for cluster creation. It's for the device setup. This you can see here. We use this script to do the basic configuration, like allow a credential setup, and then we launch an EKS admin instance using the EKS admin AMI. And after that, we can access to the admin instance to do the real cluster creation.
Got it.
So there are some.
Sorry, go ahead.
Oh yeah. So kind of when you receive the device, you can imagine that like during transport, we don't ever want it to be tampered with. So only the person who have access to it should be unlocking it. So this is sort of what we're emulating here, where there is a couple steps before when you receive the device, you have to unlock them, and the script really kind of just automates that so that it makes it a little bit more seamless and gets everything up and running.
Okay, so if I had a one-track mind, all I want to do is run EKS Anywhere on Snowball. I get the Snowball devices, then feasibly I could essentially just SSH in and start with this script, right? And it'll actually deal with unlocking the devices, setting up the right IAM policies, getting it prepped to create a cluster. We haven't done that yet, but we're getting it prepped to create a cluster.
Yeah, that's true.
Got it.
Exactly. Yeah.
Okay, it has the EKS-A admin instance created, and also create and copy the credentials to the EKS-A instance. And then it also provide a command for user to access to the admin instance. So let's copy this command here and access to the instance. Okay, then we are here. The script also create a cluster config for the user with the desired cluster name. You can see here, this is the cluster configuration. Let me open that file.
So that was created for us, the cluster config.
Yes. You can see here, this cluster config has all the fields pre-filled in, like the cluster name, port setter, and the control plane endpoint, and also the version. We have a default node count of 3, and there are also some other specs like the device list. The script also fills this device list with the device IP configured in that config.json file. Yeah, that's pretty much of it. It's all proper configured, and we also provide create cluster script in this temp folder, and with all the commands we need to create a cluster. So it's here.
So I think now we're getting the part where Ela was mentioning before, having that whole script that also just kind of kicks off the cluster.
Yeah, so that's a simple script. We need to export the credentials and then just call the EKS-Cattle to create a cluster.
Here we go. So we're not reinventing the wheel here. EKS Anywhere is built to support other form factors as well, and you're leveraging the same APIs and tooling that EKS Anywhere Cuddle uses for Snow devices as well.
Yeah, exactly. So with that, I just need to simply run this script and let EKS Anywhere to create cluster. Okay, you can see the process started. We will try to put some container images to set up the EKS-A environment, and then start the cluster creation. Okay, this process will take about 15 to 25 minutes. So while we are waiting for it, I can show how to deploy a service on a pre-created cluster on Snow.
All right, love it. Let's switch to one where the step has been done, right?
Okay.
I guess we have the benefits of TV cooking magic, where we have another cluster already pre-set up.
Hey, no, I'm going to hold you to it. Yushin, we're going to come back in 15 minutes. I'm going to make sure that this is completed. So.
Yeah. Okay, let's switch to another terminal. And here I have a cluster already created. Oh, sorry, I need to.
Cube config.
Yes, I select cube config. So here's the cluster that's for the demo, and we have three control plane nodes and 3 worker nodes in the cluster. All of these nodes are in running state. Here, 3 control planes and 3 workers. And this cluster also created on that 3 devices. You can see here, we try to allocate the nodes evenly on the device. You can see here. So each device has 1 CP node and 1 worker node. Okay.
So
Yushin, go ahead.
Sorry, go ahead. So basically, since we are having it in the 3 devices, we are having the aspect of high availability here, right, for both control planes and data plane. Is that right, Yushin?
Yes.
And so I guess I'm looking at the IP addresses, and I see there's one for 1.76, 1.109, and 1.177, and each of those correspond to the 3 Snow edge devices. And it looks like, you know, we've got 2 control plane nodes on two different Snow devices, and then the last. So actually, no, it looks like we've got 1 control plane node per one instance. Perfect.
Yeah,
that's the way we want it.
it's also the same for the worker node. Okay, then we have this class ready. Let me deploy a example service on it. I'm going to use the Yelp service. First,
right. So for the folks that are watching, Yelp is a pretty popular sample application for working with Kubernetes containers, really. And it was developed originally by Massimo De Rufere. So I'll drop a link to it in the chat here, but super cool demo app that I think if you work with AWS and EKS, you've probably seen this demo app featured some way or another. So this will be cool to see it running on EKS anywhere on Snow.
Awesome. So first thing I want to do is to create a namespace to host the service. Okay, the namespace is ready, and then I'm going to deploy the service using the service definition YAML file. Okay, you can see the services and deployments are created, and then let's check the deployment status. Okay, you can see here the container is being created. Let me check again. Yeah, I think this can take about 2 minutes.
Right, it's got to pull the container images, right, and actually.
Yeah.
Okay.
Okay, I think we can. At the same time, let's switch to
Should we
the
dig into
other.
one of them? Should we see what's going on? Do a describe?
Watch.
You can also be patient. It'll probably come up eventually.
Yeah. Select something happen.
Yeah, let's describe one of these pods. See what's going on.
Okay. Sorry.
If you haven't been on Container from the Couch, we love doing it live. This is common.
Yep.
So he was able to pull the image. Oh,
yeah.
Container started. See, we should have just been patient. You know.
Yeah. Okay. It's running.
It's running. Yeah.
Nice.
Yeah, because.
So see, it's assigned an IP address. I'm guessing that's on the local network.
Yeah, that's not local network. That's the cluster network.
Right.
That's,
the pod network, right, Agent?
Yeah. Still have one container in progress.
Yeah, the pesky DB.
Let me check the status here. Okay, started. Yeah.
It's like every time we check, it just starts.
Yeah, what's up with it? The second we check, what's up?
Okay, then let's
by the way, EKS Anywhere now on quantum computing. As soon as you inspect it, the state changes. Sorry, totally kidding.
Okay, here we can find the node which hosts the UI container. So normally we can access this IP address using our web browser, but since the devices are in our lab, it has some network restrictions. So I need to do some port forwarding to enable access to this IP address. Let me do it.
See, what I think is so cool about this is that we've got this device, this rugged Snow device that, before we set anything up, it was just hardware at the end of the day. And now, just in the matter of the last 20 minutes, we were able to install Kubernetes on it. And now I would feel confident giving this to any Kubernetes expert on the planet and saying, hey, run your applications, run this, run that. It's a standard Kubernetes environment that's running on a box that can fit on your desk. That's pretty cool to me.
Yeah.
If you think about it, it's kind of crazy. Like, you can bring these devices anywhere in the world and have a Kubernetes cluster running just wherever you are.
Right. You were mentioning some use cases at the cruise lines. I never thought of that, but makes a ton of sense to be able to have something, that's the perfect example of a DDIL environment, right?
Exactly. It's like, like 3 weeks on end, they're out at sea. Like, this thing has to keep running, but they can always occasionally come back, phone home, connect it back to internet, do the upgrades, do whatever they need to do, and then send it back out and, rinse and repeat, right? And that's kind of what makes it cool.
Right. And hey, awesome, Yishin, we've got the demo app running. I don't know, this might be the first time Yelp is deployed on EKS Anywhere on Snow. That's a landmark right there. That's awesome.
That's awesome. I just forward the IP address to my local host, and then I can access the web server using my web browser. So
that's really cool.
Vote.
Yeah, that's really cool.
Yeah.
All right. Okay. So what have we seen so far? We've seen the process of setting up the EKS Anywhere on Snow devices. We saw creating a cluster. Now, Yishin, I don't know if I'm giving enough time here, but you said that process to create the cluster, the 1.23 cluster, would take 15 minutes or so. How are we looking on that?
Let me change my tab. So you can see here, it already has a one control plane ready and creating the other 5 nodes. I think you'll need another 5 minutes.
Excellent.
I think.
Okay, we'll give you a little bit more time. Now, Ela, I know that we wanted to showcase the Conformance framework, right? So if you want to go ahead and start sharing your screen, we can jump to that. Yishin, I'm not going to forget. We're going to come back to you, and we're going to see the cluster upgrade process. But while we wait for that to come back up, Ela has been working on something with his team here at AWS, and I'm really excited to give him an opportunity to show it live here. Ela, are you ready?
Yeah, I am ready. And before I show a live demo, I just want to talk about why we built this framework in-house within AWS, right? First is, so basically with the Snow launch now, we have 5 different variants of EKS, apart from EKS on the cloud, where you can run production workloads. Like what you saw, EKS Anywhere on Snow, we do have EKS Anywhere on vSphere, we do have EKS Anywhere on bare metal, and we do have EKS local clusters to run on the Outpost. And then we also have EKS Anywhere on Nutanix. So which means that we have 5 different deployment models apart from EKS on the cloud. So we have constant asks from our ISV partners, like the software partners, hey, can you give me access to your environment where I can run my software? Or can you just tell me the procedure how I can buy this hardware, create this EKS Anywhere, and then validate my product, right? Which means that it's a heavy overhead for them to buy the hardware and also use a lot of personal time to get the cluster running, and then obviously getting the software validated. So that is where we work backwards from that thought process, and we came up with this idea of building a conformance framework. So what this framework is going to do is, we have our own labs. Like in my house, I have my Snow machine sitting right next to me. I have my vSphere environment running EKS Anywhere. I have my Nutanix environment running EKS Anywhere. And I do also have my Outpost environment running EKS. And I also have my bare metal environment running EKS Anywhere. So which means I have my own 5 different labs having this EKS Anywhere up and running. So all I have to do is just help my ISV partners, and they can start running their software. So which means that what they can do is, what they're supposed to do is, all they need to do is come up with a Helm release of their software, right? That is what our partners did. If you see this page that I'm sharing right here, what our partners did is, we have this framework here, we have this open source Git repo here. So we have our partners, not in any particular order, HashiCorp, System, SUSE, Dynatrace, All these partners, what they did is they started submitting pull requests with their Helm release into their of their particular software into this particular repo. And so what we did is, under the hood, I have my EKS cluster up and running here. And you see here, I have synced, I've done a GitHub sync of that particular repo that I was talking about, which has all my ISV softwares, ISV partner softwares into this particular cluster. So which means that as soon as they submit a pull request for their particular software, in terms of Helm release, as soon as we approve the pull request, their software is going to run in all our labs. So here what you see is it is running in our Snow lab. But likewise, as soon as the pull request is approved, their software is going to run in all the 5 different labs and validate whether their particular software is up and running. To be very specific here, let's talk about HashiCorp Vault. So what you see here is, as soon as the GitOps repo is synced, as soon as the Helm release is up and running, you can see the software is up and running here. So what I'm trying to say here is, there is not a lot of heavy lifting now the partners have to do, or our software partners have to do. All they have to do is submit their pull request into this particular GitOps repo, and as we validate it, approve it, they're going to see that software validated, less heavy lifting for them in terms of using these deployment models. So that's precisely what we wanted to see here, right? So talking about this GitOps repo, where you can submit your pull request. So talking about our validated partners, particularly for Snow launch, we validated 5 different partners: Dynatrace, OneAgent, we validated KubeCost, we validated SUSE, we validated Sysdig, and HashiCorp Vault. So all these 5 partners are featured in our as the launch partners in our GA blog. But what I'm trying to say here is, this automated approach using GitOps really helped our partners to validate in a very quick fashion versus they spinning up their clusters, they running their software to say whether it's working fine or not. So that's the approach we took in terms of validating our partners using this conformance repo, framework that we built in-house.
Excellent. So Ela, just so I understand it correctly, without a framework like this, the vendor would have to essentially run their own, EKS Anywhere on Snow, their own Nutanix, their own distributions, just to validate that their install works correctly. And they need to do it every time their Helm release goes out. And to help them with that process, essentially now we have this framework in place. Now, I guess Absolutely. I want to ask, what exactly is the framework validating? Like, how in depth are we getting? Are we running like tests against this? Or are we just deploying the Helm chart? What exactly are we doing today?
Yeah, that's a great question. Thank you for asking it. There are 2 different aspects to this particular framework. One is clear cut. We need to get the software up and running using the Helm release. And that is what you're seeing here. KubeCost did submit their Helm release, and then I think now the software is up and running, and you see that it's fine. But the second important aspect of this is basically functionally validating whether their software is up and running, right? And that is where I can just show you another example, right? We have this particular job. This particular job that was submitted by HashiCorp Vault. What this job is basically going to do is, it's going to show whether that particular product is up and running. So as you pointed out, right, there are 2 things that a particular vendor has to submit in order for them to validate their product. One is obviously submitting their software using their Helm release. That is what we were talking about here. And that's what you see here. That's what HashiCorp submitted. But second thing they also did is they submitted a test job, like what you see here, right? This test job is basically going to validate whether the HashiCorp Vault is functionally working fine. So which shows us the conformance that that particular ISV software is installed fine, plus that particular software is also running fine through that test job. So test job is an essential pull request approval criteria for us to validate that particular partner.
Got it. I think this is really interesting that we're helping customers do this. Do you have any plans for moving forward, how we can, get more partners onboarded into this flow? Is this kind of like a required part of onboarding for them today, or is it kind of more recommended to help them ease some of these concerns?
So definitely from AWS, we recommend this approach, is just because they're going to have the lightweight of just submitting their Helm release, which they already have, and we do the heavy lifting. We highly recommend that, but it is not essential that partner has to go through this path always. But we are having a go-to-market motion to reach out to our partners and have them participate. And we have tons of partners lining up to participate in this particular framework. But it is not that it is mandatory, but it is recommended from our end to make it pretty easy for them, validating across 5 different deployment models we have to run in hybrid and edge scenarios.
Got it. Now, one of the questions that I had when you were talking about this, say something does go wrong. Like, how do we notify, I guess, the vendors that, hey, your build is failing? You get it fixed.
Yeah, that's another great question. I was anticipating this question, as a matter of fact. So what we have is something called a bot running within our environment. That bot is going to constantly communicate with Slack. So, for example, I was running my Snow environment. I was just starting my job. It initially failed to run a particular pod. It's just because the readiness is not working. And we also had few failures. So we are doing alerting through Slack. So what we do is whenever a vendor is trying to work with us, we will try to add us to the Slack channel to make sure they can validate whether that particular product is up and running. That's one mechanism. The second mechanism that we have, the first mechanism is alerting, of course, which I was talking about. The second mechanism is reporting mechanism. So what we do as part of this Conformance framework is we create a daily job which runs nightly. And what it is going to do is it's going to collect the state of all the Kubernetes resources that is running in the EKS cluster. And we opinionatedly on demand send those reports to our partners as well. So which means that partners have a mechanism to see what is the status of their Kubernetes job, apart from we manually telling them what's going under the hood. So that's the mechanism we have deployed. And we are also going to improve the framework to have monitoring and also planning to bring in many features as well. But at this point, we have alerting mechanism and reporting mechanism to help partners identify their issues in their workloads of the softwares they're submitting.
Got it. Okay, I've got one more question for you, and it seems like you can tell the future here with the questions I've got. Hopefully, this one doesn't trip you up. Now, EKS Anywhere is Kubernetes conformant. It's a Kubernetes conform. It uses a Kubernetes conformant distribution, right? It's EKS-D at the end of the day, which is tested with the upstream. We've gotten the golden check mark from the CNCF. Given that it is Kubernetes conformant, why would we need to run an additional testing framework to validate these third-party vendor solutions?
That's another great question, Sai. So I was talking to you only from the software angle, right? ISV angle. There are a couple of other angles this framework can also solve, which is what I want to talk about because you asked this question, right? So let's take an example. We have an hardware partner, an IHV, who has come up with an hardware. He has an hardware that is there, and he's deployed this EKS-A distribution on that particular hardware. Maybe it's a bare metal distribution that we have deployed. So how are we going to make sure that particular EKS-A software on that particular hardware, which we have not validated, we're going to say whether it's Kubernetes conformant? That's the first problem we are solving here. Any random hardware installing EKS anywhere, whether that particular EKS distribution is doing what Kubernetes is supposed to do, all the things that it is supposed to do. So that is the first thing this framework can solve. And the second thing is we are also providing a seamless mechanism for you to deploy ISP softwares without going and searching anywhere or without working with many ISP partners, right? You can deploy ISP softwares directly using this framework on that particular EKS-A distribution on that particular hardware and say it is conformant, right? So that's the mechanism we have here. And plus there is also an industry angle we can talk about. So let's say you have a hardware, let's say you've deployed EKS-A on that hardware, and then you have deployed an industry solution like a telco solution. Like let's say you have deployed a particular telco software. How are you going to say whether that is Kubernetes conformant? And how are you going to say whether ISV softwares are validated there? So that is where this particular framework, apart from an ISV angle, can help our customers to validate their conformant of their particular workloads they're going to run on that particular EKS Anywhere on a particular hardware.
Awesome. All right, Ela, can we, I'll drop a link to the framework in the chat here, but is there anything that you want to share with our viewers here for ISVs or for potential users for, anything that they can do to get started or to learn more about this framework?
Absolutely. So the starting point is this README. They can go to, so from an IS software partner, they want to participate in this EKS Anywhere Conformance. Obviously, I would highly recommend them to take a look into this particular README. Thank you for sharing that link there. So they can start working with this. They can start submitting pull requests to this repo. We will validate and we will be in touch with them. And we will also work with them to add to our community repo, which is the AWS developers repo, where they can work with us to get their software validated across 5 different deployment models, which is bare metal, Nutanix, Snow, vSphere, and also on Rover, which is the local clusters and outpost. The second thing a customer can do or particular IHG partner can do is they can get in touch with us. They can directly work with us. We can share them the secret sauce of running this framework on their cluster so that they can be conformant and they can say to their customers that we are conformant in terms of running production workloads. So that's the call for action in terms of this particular framework.
Got it. And I did drop a link in the chat here. I got it wrong the first time around. I linked to the Kubernetes Conformance, the official Kubernetes one, but I got it right the second time around. All right, Yushin, back to you. We didn't forget. We want to make sure that the 1.23 cluster you deployed is up and running. Let's take a look.
Yeah, you can see here the cluster is already successfully created, and we can get the cluster details here. Let me first export the config. So you can see here all 6 nodes already. Let's also do a get node. So 6 nodes are already evenly located on different devices, and the version is 1.23. Yeah, that's the creation part. For upgrade, that's straightforward. We just need to add the cluster config with desired value. For this one, so we want to do scale up. Let me change the worker node count to 5, and then we want to do a version upgrade at the same time. Then change this version to 4. Then we are done with the cluster config. Next thing is to run the cluster upgrade command. That's similar as our create command. So we can do a slightly modification here. Change this create to upgrade. We still need these credentials to allow EKS Anywhere access the device. And that's it. Let me run the command again. Okay, the upgrading is in progress. Just need to wait for another 15 minutes to get it ready.
Sorry, I was answering a question in the chat. But okay, so taking a look here, it looks like we've essentially kicked off the upgrade process. So it's using a declarative approach, much like you would upgrade a version of an app running on Kubernetes. You update the YAML, you apply it, and realistically, you expect it to take care of all the heavy lifting behind the scenes, right?
Yeah.
Excellent. Okay, so this is kind of, I'd say, like a day one operation. So it's good to see that these kind of basic workflows are thought of. Now, I know that we've recently GA'd. Edric, Yushin, can you tell us a little bit about what's on the roadmap for EKS Anywhere on Snow? What's coming up next?
Yeah, so I think right now we GA'd quite recently, and looking forwards, we're looking at a couple different things. The first is that we're trying to see what other hardware types we can support. So currently, customers can go into AWS Snow Console, and they can order this with an AWS Snowball Edge Compute Optimized device. We have a lot of demand from our customers who are running ML workloads, compute-intensive workloads. So, we're looking to expand this to including our GPU SKUs of the devices. So in those cases, we can have the customers who are running ML workloads, and they can access and leverage our Snowball Edge SKUs that do have a dedicated graphics card in it to accelerate their workloads. And yeah, and right now we recently just launched, so we're kind of taking in feedback. Really want to see what the community, our customers have to say, and kind of rolling all that feedback into the roadmap and seeing what we can do next. We were lucky that we inherited a lot of the goodness of EKS-A kind of off the bat, so you kind of get that right out of the box. And we're planning to continually match parity with all the other deployment options. So whatever you're getting on EKS-A, we're gonna bring into the Snow specific deployment option.
Excellent. All right, folks. Yishin, I doubt we'll stick around to watch the upgrade ready here, although it does say 6 nodes ready, so it might be fairly soon here. That being said, I want to give you all an opportunity. Is there anything else that you want to leave with our viewers today? Anything you want to share about EKS Anywhere on Snow, the future, how to get involved? Really, it's your opportunity.
Yeah, absolutely. So you have the link here. We did have a launch blog that features one of our colleagues' very, very cute dog on top of a cluster of Snowball devices. But I think this is probably the best place to start if anybody is interested in EKS Anywhere on Snow. It kind of goes through a very high-level flow, similar to what Yishin showed here, but also kind of talks about how to get started with the validation framework as well, and touches on sort of the whole use case of EKS Anywhere on Snow. So definitely start there, and I think that will kind of leave you in the right direction. And it'll also show you how to order the devices and go through all of the nitty-gritties there.
All right. Any other last words, Yishin? I do want to thank you for that awesome demo. I think it was cool to see not just the Snowball setup, but also the cluster creation, deploying a sample app, and that upgrade flow. Thank you for that demo. Awesome. Well, I want to thank all of you for joining me on Containers from the Couch today. For our folks that are watching at home, by the way, we're going live again tomorrow. I'm going to be doing a live episode with guest Victor Farchik, the star of DevOps Toolkit, as well as Whitney Lee from VMware, talking about building internal development platforms using tools like Crossplane and Flux. Same time tomorrow. Be sure to tune in. Again, thanks to my guests today for coming on today and talking about EKS Anywhere on Snow, and we'll catch you next time.
Thank you all.